Okay, here's a partial video about writing a tangent line to a graph. So this, y'all, this is the point slope form that we're going to use, right? So these three things in color are what we're going to replace in our equation. The x will always be given to you in your problem, okay? The y, we're going to calculate by plugging x into your original function, right? We're going to be given a function that we're going to find the tangent line to. So you calculate your y, and then your m, or your slope, is found by using the derivative. Okay, so they give you x, you calculate y, we find a derivative, and then you calculate m. Okay, so here is an example from your note page. We want to find the equation of the tangent line to g when x equals -2. Okay, so like I said, they always give you the x value, and you have to do some other things. So the first thing we had to do was find the y value, and I said y is green, so y. So y value, how do we find the y value? Plug in -2 into g. So we're going to evaluate g at -2. Okay, which means everywhere we see an x in our equation, we're going to put a -2. Okay, so we are evaluating our function, our g function at -2. So let's do this. Let's see, 2 times -2, Gesundheit, is -4 minus 1 over -2 plus 3 is 1. So we have a y value of -5. Okay, y value of -5. Okay, we are 1/3 of the way done. We have found the y value. Okay, now we have to find our slope. And we find our slope by finding the derivative. Finding the derivative. Okay, so here's our function. Right, this is a quotient function. It's written as a fraction. So we're going to use the quotient rule in order to take the derivative of our function. I guess my equation's a little bit, I gotta move it down here, sorry, equals. So the quotient rule says we have the low function, which is x plus 3, your denominator, times the derivative of your numerator. So the derivative of 2x minus 1 is going to be 2. Okay? The derivative of 2x minus 1 is 2. Minus your numerator function by itself, so 2x minus 1, times the derivative of your denominator, which is just 1, right? So the derivative of x is 1. There's a 1x here, right? The slope of y equals x is always positive 1, and there's no derivative for our constant, over the low function x plus 3 squared. Okay, now believe it or not, you don't have to simplify this if you don't want to, because our point is figuring out when x is -2. So you legitimately could plug -2 into all of your x's and then simplify it. But I'm going to do a simplification step first, or two, before I plug in my -2. So let's do some distribution. I multiply both of those terms by 2. 2x plus 6. And, well, I multiply both of these terms by 1, but that doesn't change anything. So now I have to subtract them. So minus 2x plus 1, all divided by x plus 3 squared. Okay, and because it's an equation, I'm not going to multiply that out to get a quadratic in the denominator. That's not really necessary. So, oh, look what happens in my numerator. 2x minus 2x is 0. That's awful nice. So I just have a 7 in my numerator over x plus 3 squared. Okay, so that is my derivative, right? This is my derivative, g prime of x. Okay, so this is my equation that I'm going to use to find the slope of the tangent line. which is exactly what I want to do. At what x value? At -2. So now I'm going to evaluate what's g prime at -2. Right? So now this is 2/3 of the way done. We found our equation. So now we're going to plug in -2 in for x. Right? I'm replacing x with -2. -2 plus 1 is 1. 1 squared is also 1. So this derivative is just 7. Right? And this is the slope. This is my slope of my tangent line. When I evaluate a derivative, I find the slope. So now I have all of my pieces that I need. I have my x value that I was given, -2. I calculated my y value, and now I found my slope. So I am golden to write my equation. So y minus, the x coordinate was, nope, the y coordinate was -5, so I plug a -5 in there, equals m, my slope was 7, so I plug a 7 in there, x minus, my x value was -2. Okay. So yes, I'm sure that you are brilliant and you know that minus a minus is a plus, so you don't even have to show that stuff. You can leave it like that if you want to. Or if you want to get rid of your minus and minuses, if those annoy you, then you can always change your minuses into a plus. Okay? And that's your answer. We wanted the equation of a tangent line at a given point, and we have given you the equation of a tangent line at that given point. Okay? Beautifully well done. You've given an x, you calculate your y, you take a derivative, and then calculate your slope. Well done.